Good morning, everyone. Good morning, Arun. Good morning, Tuhin, Ajay. So we are starting now. Again, good morning, everybody, and hope you are able to hear me clearly. Are you able to hear me clearly? Great. So only Tuhin and Arun are able to hear. Raya is also able to hear clearly. Prashant, are you able to hear me? Ajay, are you able to hear me now clearly? And great. So Prashant, are you able to hear? And Vijay, are you now able to connect? Okay. Okay, great. I think we should start now. Some of the attendees may not come today. They have already informed me because they have some prior engagement. So, okay. Yes. Okay. So, Arun's question is, before we start, this is a very good way to start. So, Arun's question is, where does merge shuffle happen? You were saying that Hadoop does it for us. On which node and server does it do it? Anybody for this answer? Just give me a second. Give me a second. I will close the door. There are ants all over. Just give me a second, okay? Hi, so sorry for suddenly muting because I had, lot of ants problem. Somehow a lot of ants came onto my desk. Okay, okay. So Arun has got an interesting question. So would anybody like to answer? So the question is, so the question, can you guys see the chat as well, where everybody chat? Where does merge shuffle happens? You were saying Hadoop does it for us. On which node, on which node or server does it do it? Okay. Okay. So in very simple words, the mer- basically the merge and the sort happens on all the nodes. Okay, and the reducer, basically the each mapper's duty is just to take their own part and do the job. Now where does and how does the merge happen? That is the question by Arun, right? So let me see your answers. So okay, so there is no answer, right? So basically, it happens on first of all, it can happen on another node also. Okay, a completely fresh node. Okay, I mean, let's say you have got a reduce. Basically, you have got two nodes which are running mapper for you, and there is a third node which is basically very free. Now, there could be two things which Hadoop can do. First one is, after the mappers have executed on the first two nodes, it can take the output of mapper to this new machine called reducer. Okay. And run the reducer on that machine. Now here the data transfer will be more, because both the nodes first and second will have to transfer the data to the second one. Okay. So the smart move from Hadoop is that it tries to figure out of all the nodes, out of all the nodes which are running mapper for you, is it optimum to run the reducer on either of the existing data nodes which were doing mapper? Because anyway, since mapper has finished, it will mapper will no longer take much of the CPU usage. Okay. So only in the existing nodes which did mapping for you take the priority for running the reducer, because there is already data on one of the nodes and the other nodes can transfer the data to that one so that it can be merged there then and there itself. Okay. So so first priority goes to the data node which has got the maximum data out after running the map. Okay, maximum number of keys. Okay, so other nodes will send their key value pair, send their key value pair to the node which is having maximum number of keys, and then that one will merge all of these keys together and run the reducer. Okay, so that is generally the way it happens. Okay, so the main agenda of Hadoop is to reduce the data transfer as much as it can. Okay. So was I able to answer your question, Arun? Okay, 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 okay. So Tuhin wants me to repeat. So let me repeat again. So let's say you have got three nodes, A, B, and C. Only A and B had the piece of file which you were trying to process. Now mapper will run the mapper, basically Hadoop will run the mappers on A and B while C is free. Okay. Now, half of the data is at A, half of the data is at B. It will be sorted. Sorry, it will be basically uh, mappers will be run on A and B, and it will generate key and value pairs and will be lying there. The key and value pairs will be lying over there. Now, and also note that when Hadoop is running mappers, the data output of each mapper is not written to HDFS. Why? because it is of no, because this is a transient data, it is anyway going to disappear. The output of mapper is going to disappear once reducer runs. So it is unnecessary to have all the backup and all the redundancy on the transient data. Now, Hadoop has three choices. Hadoop has got A, B, and C, three servers. It should run, it can run the reducer on either of the data nodes which have the data already, A and B. And there is a third server called C, completely new one. So the Hadoop's priority of running the reducer would be on A or B. Okay. Why? First, there is the data is lying on either of A and B. So the output of mapper, which is on A, will be easier to transfer to B than transferring both the data from A as well as B to the third node, which is a fresh node, uh, to the C. Okay, to the node C. So Hadoop does a wise thing. Out of the two mappers, whosoever spits out the maximum number of keys, the merging happens on that node. Okay, so there is a transfer between from A to B, and the merging will happen at B if B has got maximum number of keys. All right, and once merging happens, then the reducer will run here, and the data, the output of the reducer is going to be pushed to HDFS. Okay. So was I clear now, Tuhin? So the transient data, so hope Arun's next question is, does transient data has separate storage or it is always in the memory of node? Okay. Okay, let me complete the first question. A follow-up question by Tuhin. So that happens randomly based on which node has got maximum keys. Yes, it's a function of two things: which node has got maximum data and which node is maximum free. Okay. So it's a function of those two things. So Hadoop tries to optimize the data transfer as well as the uh, um, evenly distributing the CPU. Now, another interesting question. So, as Arun asked, does transient data has separate storage or it is always in the memory of data node? Can somebody quickly answer this? I just answered it. Let me see who heard it. So, does the transient? It's an interesting question. It's a good question actually. Okay. Okay. No, actually, the transient data, since since we are dealing with big data here, remember, since we are dealing with big data, we really cannot afford to put the data into memory, and this data is not 10 MB or 20 MB. It is in terabytes. Okay, so we cannot really push it to the memory. So transient data, as we are talking here, Arun, we are actually we, as I understand, the transient data uh, in your question means the output of mappers, right? When you run mapper, they will spit out key values. Where would the each mapper store this intermediate data? Because each mapper would be having their own set of key values, because the file it is operating upon is split onto HDFS, and it is being run on those data nodes. Now, okay, okay. So Venkat says it is data node. Yes, it will be in memory. Once job is done, it will be less. It will not be in the memory, right? Twin, because the data is huge, so you cannot afford to give memory to it. I have at most seen some 120 GB RAM so far. Okay, and this data we are talking about might be in hundreds of terabytes, right? So we cannot have that. So basically, generally there is two confusions related to the output of the mapper. Mapper will run on each machine, take the data from HDFS, each chunk, and will process it and generate key value pairs. And once key value pairs generated, now there is two confusions generally. Will this output of each mapper be stored on HDFS, or will there be any other mechanism, right? So it is stored on the file system, local file system, temporary files, and then gets merged to the other nodes. Okay. Yes, the screen. Yeah, Prashant, the screen is only first. I am trying to answer Arun's question before I start. Okay. Okay. And yes, and also merge the data. That is why I asked question, as data node supposed to have less RAM. Yes, yes. So data nodes, basically, we do not demand too much of RAM or some extraordinary amount of RAM from the data node. Okay. Local file system of nodes. Yes, 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 you are right, Arun. So the it will be ext3, ext4, or NTFS on Windows, and so that local file system is what is going to be used for intermediate output. Once reducer runs, transient data will not be present anywhere. You are right, Ireya. It will not be present anymore. Yes, Tuhin, you are right. So it stores on the disk, but not on HDFS. All right. So should we move now? Okay, I got some more very interesting questions. So do we need to configure it somewhere and configure about which FS it should use for sorting etc? No, actually, by default, it uses the local file system. All you need to define is your temporary folder in case of in the settings. Okay, and by default, /tmp and /user, and there's some other naming convention is followed for doing all to for creating the files. So Venkat's question is interesting. Does mapper and reducer run in all data nodes? Can somebody answer this for me? If not, I'll answer. Let me see who all learned. So does mapper and reducer run in all nodes? Yes. Excellent, excellent. Okay, right. So I mean there are basically two answers to this. For the first time, for the first time, Hadoop has no knowledge about your mapper processes. Okay. So Hadoop will only run where the data is present, as Ajay Karthik said. It will run only on the data nodes where the data is present. All right. And later on, if it and Hadoop gathers metrics on every run of your program. Okay. And as per the metrics, it realize that your program really needs too much of processing. And in those exceptional cases, in those exceptional cases, it might run on more nodes than the more nodes than the data nodes. Basically, data nodes containing the file, so it will run on more nodes than the nodes containing the file. Okay, does that answer your question? Great. Can we give output of one mapper to another mapper before giving it to the reducer? Why would you like to do that, Arun? My question is, why would you like to do that? But if you do, can you do that, you can also do basically in the single mapper. Okay, okay. No, actually, you can't do it that way. You will always have to do mapper reducer phase, then another mapper reducer job, and so on. And to connect all of these, the sequence of things, you will have to use Uzi kind of framework for for connecting map reducer jobs together. Or even if you don't do that, a simple shell program which executes in sequentially will do your job. Okay. So, and actually in that one, right, mapper, the output of mapper will have to go through the reducer and then we'll have to do. But your thinking is correct. Just give it one more thought and you will be clear that you will require the full phases. You will require the full phases. Okay. All right. Now, very interesting questions. Now let's move on today. And okay. So today we are going to cover streaming jobs and discussion on the problems which we had already. Okay. So first of all, I would like to explain to you a very simple way of doing things. Okay. So before we get panicky here, okay, ignore these parts, okay, these first three lines, okay, and just focus on these two lines. Okay, so there is a concept called streaming jobs in MapReduce. It is basically a library which makes it possible to use any binary as mapper as well as reducer. Okay, it it is basically a Hadoop library which makes it possible to run any program as your mapper or some other program as your reducer or same program as reducer. Okay, so your mapper or reducer doesn't have to be a Java binary or particular program binary. The only restriction on having mapper or reducer binary is that it should be available on all of your data nodes because it has to be executed on any data node or it has to be executed, the mapper has to be executed or reducer has to be can be executed on any of the nodes. So this binary has to be present on all the nodes in your cluster. Okay, and this is what it is. So here, for those who are not very aware very much aware of the Unix. Let me explain to them once. So first portion says that, let's look at the first line. Even if you have never seen this, it says, it tells Hadoop that we are going to use Hadoop streaming. This portion, the selected portion, says to Hadoop that we are going to use this streaming jobs. Okay. So this is for executing streaming jobs. A streaming job means we can execute any binary as mapper or reducer. All right. Now, this is my input folder. This is the input folder which we are going to have. Okay. Just a second. Okay. This is my input folder, which where my files are lying. So we give a folder generally so that we can put all the data together. All of the files contained in input folder will be concatenated and give to the and the portions will be given to each of the mappers. Okay, if there are 100 files in this, they will all be concatenated together, and on that the map programs will be run. This is the folder where the output of your program will go, and this folder should not exist. Okay, in this folder there will be few files created. First file will be your log file, and second file will be, then under this there will be multiple file by the name of part 1, part 2, part 3. So each reducer will be creating one part for you. Okay, if you have got 10 parts in it, that shows that there are 10 reducers. Okay, but by default there is only one reducer, and hence you will only get one single file. All right, and then you are passing your mapper job. Now let me freeze for a moment. Here, look at this portion. This portion is Unix way of saying replace space with, it's a command line. As I showed you, it's a command line which basically replaces a word with another one. Okay, let me show you. Can you see my black screen? All right. Say, I say echo hello. Echo hello does nothing but prints that word onto the screen. Okay. In the similar manner, if I say echo hello and substitute ll, let's say I'm just okay. Let's say we are trying to substitute o with with dot. Okay, and yeah, so this command means substitute, or let me be very simple. Substitute small a with capital A. All right, substitute small a with capital A. Okay, so whatever ABC became capital A and then B and C. Okay, it's like control F. So SED takes input from echo. This pipe in Unix means the whatever input is coming from the previous command is considered as input for this one. Whatever output of the previous command is the input to the next command, and then you can replace uh, something with another thing. Here I'm replacing small a with a capital A. Okay. So similarly, in this case, if you see, if I have a name called Sandeep Space Giri, and I say substitute space with new line. That might not work here. Okay, so substitute this with new line. Okay, so it has replaced space with a new line. You see, Sandeep and Giri comes in the two different lines. Okay, so that is what is the job of this command right now, which we are seeing on the screen. It will replace space with new line. Okay, so your lines will become one word per line instead of multiple sentences in a line. Now, the second one is reducer. Reducer is another command which we are passing. Its job is to just find out the unique counts. I'll show you what does it mean. So let us just imagine for time being we have got two words Sandeep Giri and Giri. So we have got two words here. If we pass it to unique minus C, it will list down the frequencies of each word. Okay, but it should be first sorted by somebody. If I have this like Giri, Sandeep, and Giri like this, it will not be unique minus C, will give wrong results. Okay, you see, it has listed down the first Giri as 1 and second Giri as 2. Ideally, it should be doing the sorting for you. Okay, so if you do the sort command before unique, so whatever output of this whole pipeline is first passed to a sort command. So how will it look? It will sort this thing by, so let me go step by step. Okay, let me go step by step. So this is the output. Once Giri space Sandeep space Giri is passed to the replacers SED, which has replaced space with a new line, you get this output. Okay, and in case you do not sort it first, if you do not sort it first, then basically you will get wrong results as in this case. Okay, now you would require it to first sort and then unique minus C. All right, so this gave us the frequency. Okay, so now you can imagine that between our mapper, what is our mapper, this SED command, and unique minus C, there is one thing which is lying called sort. Okay, that sort is being done by Hadoop for you. Okay, although it looks pretty simple on the Unix command line, but since the data grows big, you require a heavy machinery to do the sorting for you very quickly. So this is the Unix way of doing, and these are called streaming jobs. Okay, so if you have got a Python program, your C# program, or any other code which you want to use for mapping or reducing, you can pass that binary name in the mapper. But remember that that binary has to be present on all the nodes. Okay, so the general way is to copy or synchronize all of your binary to your universal folder, say slash opt slash um, your company name and then binaries, all the binaries in the single folder, or other ways, and then synchronize that folder, rsync that folder onto all the data nodes in your cluster. Okay, similar goes for the Python also. If you have got Python program, so you will have to make sure that your library is present on all the nodes in the cluster. Okay, so here mapper will execute this. First it will take all the files in this folder, cat this file. Okay, instead of echo the way we have written echo. Okay, I think I have got big. Okay, minus name. Yeah, I got it. So So basically, when I am doing this, it is essentially taking this and running the first command called this one. Okay. And here the syntax is slightly okay. Okay. Now basically a cat means taking the reading the file and putting all the content to the screen, and the substitute replaced it with the replaced the space with a uh, new line. All right. And then what you can do is you can do the sort, and then you can do a unique minus c. Okay. Now this is going to take a lot of time. All right, because the file is little big. Now, this is how I would do it in Unix before Hadoop if my data is big. And here you can see the effect. It is taking too much time on the command line. Now let's take it to Hadoop. Okay. This file is not too big. Okay. This file is not actually too big. It's basically 6.2 MB. Okay. I have just truncated it. And in itself, it will take a lot of time. Now, let's see on my Hadoop node. I have SSHed into Hadoop 3. Hadoop 3 has got the same login password as told to you for the student login. Okay, so Hadoop 3.nobigdata.com is a individual node. It is not part of the cluster for the people who want to just do on a single node. Okay. So let me increase the font a little bit, and then all right. Now let me reformat my command, make it into a single line. All right. Now when I do this, in case the output folder is already existing, it should give me error quickly. So it says that word count folder output 2 is already existing. I will do output 3. So basically these commands, first mapper will be run, then the results will be sorted and then passed to the reducer. So this is doing all of the job for you. It's saying mapper 0%, reduce is 0% complete, and then mapper is finished now. The reducer is starting. Okay. There are total number of 2 splits, and it says that data is finished, and this map reducer framework gave you the details of each and everything. Total number of bytes it has read were this much. Total number of bytes written were this much. Number of read operations and number of large read operations. Okay. Okay. Hadoop fs minus cat, and then we say this. Okay. Okay. And if you say first ls, let's say first ls. So output has been created in word count output directory. Okay. And so when you are working, you should create your own folder in HDFS and then work. Here I have created a folder called users/root, and then I'm putting all my data there. So here you can see that when I said fs minus ls, ignore this warning because it wants me to compile for 62 bits. So ignore this part. Just see these two files. So one is this status, which is sort of message saying that this is done, and then there is this folder part 000. So based on number of reducers, these files will be created. So right now it shows that there is only single reducer available on the server. Okay, that is why there is a single file. So each reducer will create their own separate file in the in the in the HDFS. So I say Hadoop minus Hadoop fs minus cat and pasted the file name. So this is where it has computed all the frequencies of all the words. Okay, this will become a far better if we basically uh, also fold the remove these special characters, and then remove trims all these special characters also. Okay, and convert also, right? So how do you convert ABC? Then you say tr capital A to capital G with, right. So this way you can also truncate, and also do, instead of passing that sed command, we could also do something like substitute not of A to Z with nothing. Okay, so if you have got like this, it will be replaced with uh, if you have got, say, this kind of files, then those will be also this kind of dot and other special character, they will be replaced for you. Okay, now you can actually pass all of this, like this full command, into your mapper. Okay, so if you take this, so here what I'm trying to do is replace special characters. First, convert the first, let me just put it there. Okay, mapper. Okay, so what I'm trying to do right now is take the output of the first SCD, and then, okay, I think that's a bad idea. That's a bad idea. Okay, never mind, never mind. So what else could be done? Okay, okay, never mind. Let me have a look at the questions. Yeah. So does this mean the single reducer available, or the data size was such that single reducer was all that was needed? So basically reducers by default are generally singular, meaning a single reducer in case of streaming job, while in case of a standard Java map reduce job, there could be multiple reducer based on the need, based on the need. Okay, based on the need and available data. Okay. So right now, since it's a streaming job, it will anyway have a single reducer. And to have number of reducers of your own choice, there is a philosophy, there is a mechanism in Hadoop called combiner. Combiner lets you create multiple reducers of your own choice, and you can define how to it's not combiner, it is called something else. It'll come in the next session, no worries. So Should we trim right after creating a new line for each word and before sorting to optimize? Let me again understand. Should we trim right after creating a new line for each word and before sorting to optimize? I mean, there are a lot of things to be done in this word count program. Okay, but here, if you have to, if we need to trim right after creating a new line, why do we need to trim? Because there is no trailing space now, because space has been replaced with a new line. Okay, so we would not see any space per se. Other is that when Hadoop is doing the processing, it will give you line by line, and that line will not have the new line with it. Okay, Hadoop will remove the new line for you. Okay, so you don't have to trim. Okay, no, Hadoop will remove the new line, so you don't have to trim. What if I were mistakenly or otherwise put the reducer code in the map part? Now you can think about the output here. If you put unique in the case of mapper, it will not do much. It will just print 212121, and basically now 2 will be your key, or the number of counts which the words which occurred together. It unique will only count those, because unique does not uh, do the job if the input is sorted in any manner. Okay, also, since unique is basically will be applied on lines. Okay, so the output will be completely unexpected. You can think about it, you can run the whole example in your mind and think about it, what will happen. Okay, and also at the end of this class you should actually try doing this using this Python job. Take this example and run it, swapping the two jobs. Okay, it will run, but it will not give you a sensible output. Okay, so you don't have okay. So I think I have answered all the questions. Savita, was I able to answer your question? And yeah, Gunjan, you should give it a try at the end of this session. You should basically swap this to a reducer and take this part to the mapper. All right. Okay. So was this answer clear to everybody? Where and how did it do this job? Not this one, of course, not this one. I'm talking about this one. How did it do the job? Okay. Basically, how did this code work? How did this particular code work? Or do I need to get into detail? Because next screen is about that. So the first one replaced space with the new line, and then Hadoop sorted it, and then unique minus C was executed. Unique minus C was executed actually on the whole data after sorting, not on the individual part, and then were merged. Okay. There were not many processes here. There are only single one. The diagram is little wrong. Okay. So, all right. So you can think of that this was ga re, or you can think of this one as like this. Okay. Good. Now, so this is has to be only a singular. Okay. So I'll just remove what is not required. Yeah. This is the only one which is required. Okay, so there is single reducer, so I'm just giving you this example here. But had it been some other job, this that the previous diagram would have been true. Okay, this diagram would have been true. Okay, in case of a multiple reducer. All right, but in our case, it is only the single reducer we have. So all of this is being done by a single unique. So Arun's question is, using binaries is better or using Java code for mapper or reducer is better in terms of performance on production environment. So first, the performance is not too much of a problem. When you are executing any native command or any other, there is a little bit of lag where you load and you basically loading a binary or using executing system command is takes little more time, but performance is not impacted too much by switching between the languages. Okay, because the main chunk of your performance will be taken by the actual processing of the data. Okay, so but if you are familiar with Java, okay, and you have a little intensive job to do, then probably you will prefer to do it on basically with Java. Okay, but in case you are quite comfortable with all the scripting languages, then you should, based on if your problem is small, then probably you would like to do it quickly using existing binaries rather than starting to write your Java code, because Java code has got a little longer period of going to production. First you'll have to write the code, then compile it, then create the jar, upload it to the server, and then execute it there. Okay, and in case your program depends on other libraries, you will have to ship those libraries together. So right, right. But in case I have worked with a lot of data scientists who haven't who don't have any clue about Java per se, but they are able to get their work done using various kinds of libraries and Unix commands. Okay, so in the MapReduce. Okay, so they are doing a pretty good job without even knowing the Java. So Java is not necessarily a big constraint, but next session we will work with Java a little more. Okay, the next session, half of the session, more than half of the session will be about Java. So maybe you can refresh your bit of Java constructs, go through the first chapter of any Java book. That will be good enough for you, or any online tutorial which just tells you the syntax of for loop, while loop, this assignment, that assignment, and you will not have much of a problem. Here we are not talking much about object oriented programming. Okay, we are mainly talking about basics of Java programming. Okay, but there are certain things which you can't really do using other programming languages than Java in case of MapReduce. I will come back to those points in the next session. Okay, so I have given this demonstration. Now I want to discuss in detail the 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 uh, the individual problems. Okay, so how many of you attempted this problem? Okay, how many of you attempted this problem? You are given a large text and you have to count the frequencies of letter A to Z. Okay, first of all, fir- first of all, do we need map and reduce? Okay, can somebody answer this? Do we need map and reduce for this? This is the first problem which I gave yesterday. You have got huge text. You have got huge text of say few GBs or few terabytes. Now you want to find out the frequencies of A to Z. Okay. and why? So merge sort is needed on the large text. That's Savita's answer, because here I don't know, because just have to count 26 letters, right? So in case you are having 26 uh, array of 26 numbers, can't you just go over this file can't you just go over this file and then just count the values? And do you need too much of memory for this, or you only need 26 numbers? It can be stored in memory, right? You don't need to load the full file all at once, right? All you have to do is start reading this file from top to bottom, left to right, and then keep on counting the occurrence of A to Z. Only 26 variables, okay, which means 26 into 4 bytes. That's all. That's not even 1 kilobyte. So memory is not a constraint. Anyone? Because all you require, so you have got a huge text, you want to count the occurrence of a A and Z and other values, and have to ignore all other letters, say dot, underscore, dash, everything else you have to ignore. Now you just have to count the frequencies of lower caps A to Z. Okay. So if we need map reduce, can somebody tell me, out of the four constraints which we discussed earlier, which one will hurt us? So Ajay's answer is that it will be sequential then, right? Yes. Yes. Savita is now right. So IO will become the constraint because it's a single machine, and as Ajay says that it will be sequentially reading the file, and hence it will become slower. So we can, just for the heck of, just for the need of your IO, we will be using the map reduce. Here the processor or the memory is not the constraint. Here the IO is constraint. This is the classic case where disk IO will become the problem. Okay, sorting is not an issue. Your other things are not an issue, but IO is an issue. Okay, okay. So, but to solve this problem efficiently, you will have to summarize each of the mapper's output first before merging it with the other one. Okay, because summarizing each of the mapper's output will be easier for you than uh, basically uh, merge first and uh, then combine them together. So because you just need 26 variable, okay, so the output of mapper initially will be lot of values, because for each line you are going to spit out spit out the the frequency of various letters in that particular line, and then all of these lines are going to be merged in the mapper's output. Now if we do not combine the mapper's output first before merging, then it will be very inefficient in case of MapReduce syndrome phenomena. So the only reason we are using MapReduce here is for the IO performances. Can we distribute our file reading to become extremely fast? Okay. So answer is yes, but only for IO reasons. Okay. So the approach is very simple. Okay. So we'll talk about summarize in next one. So we'll not. There is another construct in MapReduce mechanism. Which is used for summarizing the output of mapper on that machine. Okay. So since mapper is being executed on line by line basis, okay, you can combine all the out. You can quickly summarize the output or review the output of mapper by creating it is called a um, it is called combiner. I think it is called combiner. Okay, all right. So we'll talk about this a little later. Okay, and here it is pretty straightforward actually. Okay. So unless the file your file goes beyond a terabyte size, you should not be using MapReduce for this approach. Okay. So the approach is extremely simple. Create an array, integer array A of 26 size. Scan the text character from scan the text character by character. Okay. Scan the text character by character. Increase A0 for A and A25 for Z and others in between, and and so on. And at the end of it, you will have each mapper will be producing this kind of output. Okay, and then reducer will basically sum up their frequencies. That's all. All right. Now the problem of anagram. Who was able to do this problem? You are given a huge text and you have to find anagrams. Okay, how would you exactly do that? Should I repeat the problem? Okay. In case of MapReduce, what will be the output of your mapper? What is it that mapper will be producing as output? Okay. Sorted word as in you means the each word is sorted by characters. Okay. Okay. Great. 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 So excellent answer, Ajay. Yeah. So to solve this problem, you will have to form a key which will be common between all the arrangements of the letter. Say there is a word called cat. Cat, take, act. Okay. What will be the common key for for all these three words such that they come together? Yes, excellent, excellent. So thank you, Ajay, Arun, Savita, and yeah. So you are all right. So what you do is take each word, sort the word by characters such that no matter what arrangement those letters are in, the output of the sorting will be the same for all of these words. All right. And hence, and hence you will end up with a single key. All right. So excellent. So okay, so do I need to should I explain a bit more? How does it work? Now, to bring, again, let me just explain once more. To bring the, so we are finding anagrams, okay, in a text. What is an anagram? Anagram is a rearrangement of words. Okay. Now we have to bring all the anagrams of a word together, or all the anagrams of each other together, such that such that that using MapReduce. So all the anagrams we have to bring together using MapReduce. Now, how do we form the key of each word such that all the variation of an anagram will be aggregated together? Okay. So mapper's job is to find the key, to produce a key, right? And hence, so in case of cat, act, tech, and cat, they are the anagram of each other. Now, if you order these letters of a word by alphabetically, you will be having the same sequence for all the words. Okay, okay. So Tuhin's approach is that you could do the summation of ASCII characters in the word and make it a key. But see, if you are having say, let me say, act and and b, and then, okay, so bbt, they will result in the same. Okay, act and bbt will have the same summation of the summation, and will end up together. Okay, right. But remember that approach, you have got the hang of the problem. Okay, you just have to think about in the same on the same lines. All right. So when you say summation of ASCII value, it's a very good sign that you are thinking in terms of hash code of the word. Okay, great. Now we have got uh, this kind of problem. So basically, we form the key by sorting the letters, and this is the diagram which shows you. So we had this, the cat, act, and tic tac toe, and the mapper formed this sort of arrangement. It ordered the letters of the into this form. This is the key, this is the value. For cat, ACT, A is less than C is less than T, is the key generated of cat. Basically, we sorted the characters of the word, and act has got the same as cat. Okay, because they both have the same characters but in a different order. So after you arrange them by ascending order in lexically, then you get these values. Okay, and hence CIT is rearrangement of tag, and again tag has got act, and toe has got EOT. So this is the key, this is the value. Key is the sorted arrangement of the letters. And and this line, this strict line, is the what mapper will do for you, will arrange, order these keys, and then in the reducer, these all the values of a key will be aggregated together, and reducer will give out this output. So key is this one, which is ordered arrangement of the letters. Okay, so we sorted the letters of the word. EHT is the key. Cat has got ACT because we ordered these letters of each word in ascending order. Okay, so this is the key, this is the value, this is the key, this is the value. So we took each word from the input line, and and generated the key by rearranging the letters of the word in ascending order. Okay, so okay, I missed. For each word, sort the letter. And that's what, Savita, I am doing, what you have suggested earlier. For each word, sort the letters of the word. Yeah, that's what I'm doing. So question, what if there are more than one cat in there? That's a very good point. So if you have got, say, one more cat over here, let's imagine there is one more cat over here. That cat will end up here, right? Because that will generate the same key called act, and then it will end up here. So there will be two cats in this values. So those parts will be taken care by your reducer, such that you also do a unique amongst the keys itself. Okay, should I move on? Guys, feel free to shout out right now before I move ahead in case this is not clear. Okay, because at first I thought these problems were very simple, but once when I interviewed lot of recruiters and lot of people while hiring at InMobi, I was actually uh, even interviewed the people from Yahoo, and they could not solve such kind of problem using map and reduce. Okay, so that time I realized that these problems are not that straightforward as they look. Okay. So Savita is saying that can you show these commands on terminal to see the logic flow? Actually, I have not formed these in a manner that way, but I can think of. I'll have to write some code for this. I have not written code for this because rearranging the letters of a word is not that quick with respect to the. I can actually do it maybe in the next session. I have not written this code. Basically, rearranging the letters of the word is a little tricky. It's not easy for shell programming. So I'll have to maybe pick up Python quickly and then give you a demo. Okay. So if you have any doubts about mapper reducer, let me know. I will like to explain this problem particularly a bit more. Okay. Okay. So basically, for a problem like finding anagrams, we have used mapper reducer whose core strength is sorting the data, right? So, so effectively, we have used sorting for solving this problem. So yeah. So Prashant, feel free to ask to all, not only in the private. It is okay. Okay. So Prashant has got a question. He says that I don't understand why in tic-tac-toe are not the output. So tic-tac-toe is in the output if you see. Okay. Tic-tac-toe is here. It is just your reducer has removed it. Okay. Ideally, reducer should be just saying here tick and and say the and toe and in. Okay. This should be the general output. Okay, and again this will be ordered by alphabetically. Okay. Okay, all right. So this is how your output of the reducer will look, and it will be against a key again the way it is here, and that's all right. So reducer is not really doing much here. Reducer is just producing output of what map is saying, just putting a comma in between the words, converting the array to comma separated things, and that's all. Okay. Main job is done by the mapper for you. Yes. So answering to your previous question and this question as well. So they will both, if there are two cats in the input, both will end up here. All right. And hence it will, in case your reducer is not careful enough in removing the duplicates, you will have two cats here. You will have two cats here. All right. But that's a good question, Prashant. Uh, and regarding your output in the sysout. Okay. So any other questions related to this one? Feel free, whatever, even if you think that your question is not good, still please ask. That will make our life easier. Okay. So I'm assuming that everybody has got it. Okay. In case you did not understand it, please feel free to ask. Okay. So Savita, you're right. So did you get your answer? Okay. 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 So okay. So Deepak is saying that he missed out on the last session. Sorry, on how do we determine what logic goes into mapper and what goes into reducer. Okay, that's a basic doubt. Um, okay, so let me try to do it very very quick. Otherwise, what we can do is we can have a second session with you particularly, or anybody who is interested in understanding just the basics of MapReduce. Okay, just drop me an email in case you want to have a second session. Maybe we can have it today evening or tomorrow evening, and and then we can have the details. Exactly, Tranmin. So mapper is a computation on nodes, and reducer is a combination of results from the combination of the results from all these nodes. Exactly. And the mapper, the logic will be, you have to prepare the logic inside the map is to preparing key and value. Okay. And that output of each mapper will be taken by Hadoop and sorted by key, and the values will be combined together and given it to the reducer. And reducer will combine those aggregated values in whatever fashion it likes to do. And that is the whole crux of whole Hadoop. So, so the final output is always in a file. Yes, a file present on HDFS. So far I have seen that it only puts it onto the file, and that's how that whole MapReduce thing has been functioning. But in case you are using something like HBase, you can have it in the database or in other modes. Okay. And in case you are using Pig, you can store the output somewhere else also. No, no, no. So as I told you, that each reducer will have their own separate file. If you have 10 reducer, it will create 10 separate files. Okay, so your doubt is correct that it will become a bottleneck if it creates a single file. That's exactly why all the reducer have their own file. So mappers and reducers all are executing on the data nodes. Nothing happens on the name node. Name node basically name node, here we are probably talking about job tracker and task tracker. So job tracker doesn't execute neither the mapper nor reducer. It only figures out that for this particular job, what are the machines or what are the data nodes containing containing the input file required by your job. Okay, the way we are processing here in the previous one in example, the big.txt was our input file, right? Big.txt was the input file. Here this input folder will contain multiple files, and name node will try to figure out which all machines the contain this contain the contain the various fragment of the file, various chunks or blocks of the file. So anywhere when we launch this job on any node, it will go and ask the name node to do the, or it will ask and go and I mean job tracker will basically ask the name node where all are the files, and accordingly it will make a call whether on which nodes does it need to send the mappers to. Once mappers are executed on all data nodes, it will then execute the reducer on either one of those nodes or some other nodes to combine the results. Okay, okay, okay. So, so hope I'm able to answer Vijay your question. So how do we aggregate the final result? Okay. So see, in case you need to do the further processing of your final result, one is that you can combine all of these files together. If that is not your final result, okay, if that is not your final result, then maybe you need another cycle of map and reduces. If the output of your reducer, which is whatever is the output of your reducer, if it is not satisfactory to you and you need to do further processing, a simple concatenation is not sufficient, then probably you need to think about another round of map reduces. That is your Ajay's question. How do we aggregate the final results? Venkat, how does app program process the results file? Okay, okay. The result of reducer or the mapper are we talking? Probably we are talking about the reducer here, the output of the reducer. So it will be, and which app program are we talking? Are we talking about map or mapper programs? Venkat? So Twin's question is, can I store mapper output to HBase and then query it to reduce job? No. So that is the non-configurable part of MapReduce. The output will be stored locally for the efficiency reasons. Okay. All you can do in this case is do nothing in case of reducer and just save it somewhere. Also, your mapper can actually make calls to HBase. Okay, mapper can actually make calls to HBase and store it. So inside your Java code or your other programming language code, you can make calls to HBase kind of library, and on each call, but remember, on each line, your code is going to get executed. You are going to hit HBase for each line. If you have got 10 million lines, then you're going to hit 10 million times the HBase database. Okay. Is this what you want? Okay. So enterprise app. How does app program process the result file? So the way it happens, Venkat, is here we are talking about crude map reduce. But tomorrow you will be, in case you have an enterprise app, you will have few calls to make. First, is it okay for your enterprise app to just connect to HDFS and read the files as is? Like in our case, we had, when we were doing any processing, we used Hadoop as our backend job. It's not a really active one. And whenever our job finished, we moved most of the data from HDFS to the proper database, our RDBMS database, because the results of aggregation were far smaller as compared to our input data. Okay, so we moved the data to our RDBMS very frequently. As and when our job used to finish, our it used to kick in our export job from the Hadoop to our RDBMS. Okay, so this is what we used to do, and then our enterprise app used to access our existing database itself and be happy with it. So that was, I hope I'm able to answer Venkat your question. Yes, we can connect Cassandra or MongoDB from Hadoop or anywhere by using their library in our MapReduce program. Okay, let me again explain. So probably your question, Venkat, is that how do my enterprise app access the results, right? So we have got a web application, enterprise web application, which is trying to access the result. So your web application few has few options. First one is it will directly read the file in the HDFS. Okay. In case your web application is not able to do that, or uh, i- um, is not able to do that, then what you can do is, as soon as your reduce job finishes, you can have a connector in Scoop or maybe Flume, where you can take this input and export it to a database. Okay, or your basically your enterprise app can have a third option whereby it can use a library called Hive, which can basically give a JDBC kind of a interface, Java database interface, to the results which are stored in the file system. Okay, so this is how it is generally done. And remember, it is not going to be, when we are talking about MapReduce, it is generally a batch processing which happen every night or every 2 hours. It is not very live. Okay, so those are the four options you have. First was simply reading HDFS file. For that, you need a driver in your enterprise app. Second is to have uh, Scoop kind of script running. Scoop will keep on exporting your data from HDFS to your relational database. And third one is using Hive. Hive will query your HDFS and give you the results over JDBC, Java driver. Great. Now let me answer Tuhin's question. Okay. This is how all big data users do it, export results to RDMS. Yeah, so exporting is one option, but Hive is very good way of, if you don't want to export every time, but um, you want your web app to hit your HDFS. That is also mm, okay. It is just that initial connection to HDFS might take a bit of time. It has a boot up time, a little bit of preparation time. Okay. But best way would be to export the results, because in case you are trying to churn the data, you might end up doing lot of map and reduces via Hive. Okay, okay. Can I connect Cassandra or MongoDB from? Yes. So Twin's question is, can I connect all these NoSQL databases from Hadoop script? Yes, you can do, but remember, you're going to hit these databases really, really bad, and also not really doing a great job, because you should first finish your MapReduce, take the output, and then push it to another database instead of from inside of each MapReduce job. Okay. If yes, then it is first we need to load data from Cassandra or MongoDB to HDFS, then do the MR operation. Okay, okay, okay. So if yes, then it is first needed to load data from Cassandra or MongoDB to HDFS and then to, okay. You mean to say that can the input from Cassandra or MongoDB be the input for your MR, right? That's an interesting question. So for that, I'll first tell you that I have actually uploaded a video on how to connect MongoDB from Hadoop. Basically, your data is lying in MongoDB and you want to do the MR operation inside of Hadoop, right? So the data will inevitably have to be copied in case you are running MR job in Hadoop. Okay, but MongoDB and Cassandra both have come up. I think Cassandra also recently have come up with their MR job. Okay, MongoDB for sure has their internal inbuilt MapReduce paradigm where you can execute mapper on each section of documents and then save and then does a reduce job distributedly on all the MongoDB cluster. Okay. So I'll have to check Cassandra if they have come up with the MongoDB map reducer. But Cassandra also supports storage on HDFS, which means some of the rows of a table are going to be stored on one node on another, and then you can run a map reduce job on top of that the Cassandra. Okay. And Hive is one big utility in these cases. You should always look at the Hive when you are trying to connect multiple things. Okay. Now I've got Arun's question. So Hive RDBMS option is for old application which are not using HDFS directly, but we could have new application which work on HDFS. Yeah. So there is another reason other than legacy reasons. There are other reasons to use Hive or other Scoop. The reason is in HDFS, the data is stored in the form of files, either tab separated or whatever. So it's not structured. So every time you are going to read it, you will have to parse it. Instead, you just parse it once and push it to the database and keep on accessing it from there. And when you have newer data, you just delete the old one, push again from the plain text to the RDBMS again. So that will solve your lot of problems. Okay. In case of using Cassandra or Mongo, would they really replace the functionality of HBase? No, no, no. I mean, they all are competitors. If you are into a complete Hadoop ecosystem, you probably would appreciate you in case you're using Cassandra or MongoDB. I mean, it is completely a business call. Because in case of HBase, you need to install Hadoop first. Okay, because HBase works on the top of Hadoop, right? While in case of Cassandra or MongoDB, you do not require Hadoop first. Okay, so in case you and they both all have their own utilities. They they all have their own utilities, such as MongoDB is a document storage. Cassandra has got secondary indexes as well. So if you we will do a comparison in one of the cases in the last session. Okay. I'm planning to have 11th session, which will be basically a comparison. Okay. If data is stored in RDBMS and if customer wants to migrate to Hadoop, any tool is there. Yes, Vijay. In the if you have my previous slides, okay, I will just take a quick walk here. So last one, this is the one. Okay. Yeah. So your question is, if your data is stored in 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 RDBMS, then this scoop which moves the data from structured to unstructured to HDFS is one of the your solutions. Okay, and this can move the data back and forth from here to even HBase. Okay, from here to HBase. All right. So these are very important tools. They help you doing importing exporting data back and forth from relational to HBase, and the whole industry has understood that RDBMS and the NoSQL have to coexist forever. Okay. Was I able to answer, Vijay? Tuhin's question is, I have will take that after session. Okay, okay. Feel free to drop me a message and then I will answer. Okay. Now, good. This is a very interactive session. I'm happy that you guys are asking question. Makes me feel that that the objective of class is successful. Okay. All right. So, do you guys want to take a break? Let's meet at 8:52. 10 minutes break. Hey guys, I'm back. Great, great. So should we start? Great. Okay. Are you guys back? Should we start? I think some of the people have not reached. I think okay, but I'll still start. Okay. All right. All right. Now, the next problem which we had discussed and asked you to think about is DNA. A file containing the DNA sequences of all the people. Okay. Find all the people who have the same or mirror image of DNAs. Okay. So this is the way it looks like. So this is your input. It's a user one has got a DNA called ACGT. User two has got TGCA. So we have to group together all the users which have the same DNA. So if you have to, the problem was just the part like all group all the users together who have the same DNA. What will you do? What is it that you will do? What will be the key of the mapper? If the problem was just that find all the people with the same DNA, okay, key could have been DNA because mapper will the Hadoop will sort your data by the key and aggregate all your uh, data by the key. Okay, so all you need to do is make the DNA the key for the data, and that's it. You are done, right? But here there is one more condition attached. It says that two users are same if their DNA is either identical or their DNA is mirror image of each other, or mirror image as in the reverse of each other. Like for example, ACGT and TGCA are exact reverse of each other. So if you have to group user 1 and user 2 together by the way of mapper, you'll have to generate a key which is same for only both of these. Okay. So any suggestions? How did you solve this problem? How would you, what is it the output going to be? What is the output going to be of your mapper? What will be the key and what will be the value of the mapper? Can anybody tell me? Even if you had to do the same thing using your standard database, you will generate another table with a key, and then you or what you could do in case of a database, you join this table with itself and then put a AND operation saying either the DNA of a user is equal to the DNA of another user, and DNA of one user is reverse of DNA of another user, and user ID of first one is not equal to user ID of second one. So in case of SQL, that is pretty straightforward. Now question to you is, can you use group by clause without doing a self join in case of SQL? Basically, if can you group form a key which is based on this table such that we can pass it to group by, okay, and group all these users together. So DNA is the key, good. Then it will get all the users with the same DNA with the come together. Exactly. So Arun's question is the maybe the logic should be key is either the reverse or the key itself. Okay. Whosoever is smaller, whosoever comes first as in ascending order, either the key or the reverse of the key should become the key. Okay. Like in case of AGCT, so you do a reverse of AGCT, the key will be AGCT itself. Okay. So the reverse of this and this is this one. So you have to choose one of these. So you choose the first one. Okay. So you keep the key for this DNA as AGCT itself, and for this one you reverse it, and reverse will be ACGT. And after reversing, you realize that the smaller is AGCT, so the key for the user 2 is going to be ACGT itself. And this diagram will explain to you. Okay, I'll show you this. So basically, we have to group these users together by DNA. Had it been that we are just grouping the users when their DNA is identical, the problem was simpler. You just group by that particular column. But here, the problem is that we have to also group users together who are reverse of each other. Okay. Had it been I mean, so we have to find out the reverse of the strain, reverse of DNA, and see whether we can group it together. All right. So here what I have done is took user 1, and the user for user 1 the key is ACGT. For the user 2 the key should be either ACGT or TGCA or ACGT. Why ACGT? Because it's a reverse of this one. So the smaller of DNA or the reverse of the DNA should be with the key. Why are we doing this? Because we want to group all the people with the same DNA together, okay, or mirror image together. Can anybody? Is it clear to you guys? No. If you have to group these things together, so or you can see this way. So we have got AGCT. The reverse of AGCT is TGCA. Minimum of these two is AGCT. Minimum as in if you order in the dictionary, which one will be smaller? It will be this one. Yes, yes, Savita, that's what I mean. Smaller means in this ascending order, who will come before. Yes. All right. So here the challenge is to figure out what should be the ID. Okay. Had it been simply a question of finding users with the same DNA, you will simply make the DNA as the key. Arun's question, it means we should try to make input for reducer as simple as possible. Yes, in this case, we are trying because reducer will have no way to group the users together. Okay. Okay. So in case of simply if we had to group people by their DNA, it could have been simply make the DNA as the key, and then it will automatically be grouped by Hadoop for you, all the people with the same one. Now we have to create a key which is same for all the people with the in the same family. And what is that key going to be? Okay. The key, if we just reverse all of these DNAs, then the first one will become the reverse of it. And hence, again, that doesn't solve a problem, right? So you'll have to compare the reverse of the DNA with the DNA itself, and whichever is smaller or whichever comes first in ascending order will be the key, or whichever comes last. Whatever you choose will be up to you, but result should be same for the same family of DNA. Okay, same family of DNA is defined as the people having exactly same DNA or exact mirror image of the DNA. Okay, and for and just for this that it is just for the problem's sake that I'm saying the mirror of the DNA should be same. It is just for the problem's sake. I really don't know how do people match DNAs. Okay, this is just for the problem's sake I'm doing it. Okay, if we are looking for smaller, why ACG user number 5 will not come first instead of user 1? Yeah, you are right. So here, if you see ACG user 5, it has come first after sorting. Okay. Right now, the mapper did not sort anything. Mapper just did spit it out all the output as is. Okay. It did not reorder it. But in the next screen here, it got sorted the way you are explaining. The migration from this point to this point is done by basically our mapper, I mean Hadoop. Okay, from here to here. All right. So this is little tricky problem where we have been successful in finding the keys for this sort of problem. In a number of cases, you may not be able to successfully create a key which combines together the two people. Let's take a case of say fingerprinting. So fingerprinting, you are given a big file. Each line contains the binary data of a person, a person's thumb impression. Now you got to, and you have to find out if there are duplicates in this data having the same thumb rule as thumb impression. Now you will have to come up with a key which basically identifies the thumb impression. Okay. And in some cases it is possible to come up with a such key, and in some cases it is not possible at all. Okay. Like for example, nowadays it is possible to fingerprint the audio music, for example. So if you have music files, a lot of music files, and you are provided as input, now your mapper will have to create a number which uniquely creates a key for this music. It's a basically, and it should be able to produce a number, and that is a very very difficult game. So in the problems where you have to compare one data against other data inevitably, and you are not able to come up with a key which identifies uniqueness a particular user, then you cannot use MapReduce in that case. In the cases where you have to compare one record against all other records, or one data depends on the previous data, in those cases MapReduce will not be able to solve your problem. So this is clear to everybody. Okay, great. It is a little tricky to identify keys, yes, and that is what takes a bit of eh, you know, skill and a little bit of thinking in terms of how what do we get. Okay. Yes. Uh, what is the and what is the value here? Which one are we talking, Ireya? Can you just repeat? What is the key and what is value here? Okay. Here the mapper has produced key and value. Okay. Now key is minimum of either the DNA or the reverse of DNA. Okay. Either the DNA or reverse of DNA. Okay. That is the key. All right. So you can think of it in terms of this. Okay. Now, if you see in the first case, the minimum of AGCT and TGCA is AGCT. Similarly, in the second case, the minimum of TGCA and AGCT, this will be TGCA, and uh, in the user 2, TGCA, and uh, TCGA, it will be AGCT. And similarly, for all others, it will be the same keys. The mirror image is still returned the same keys. Okay. Or maximum also would give you the same output. Maximum as in the greater of the two. Why it is minimum or why is greater? Because this starts with A while this starts with T, and hence this one is smaller. Okay. So this is how this is little tricky, but you will get used to it, and you will be able to, once you are able to figure this out, then you will be able to solve a lot of problems. But nevertheless, it is not so easy in lots of problems to identify the keys quickly. So there is no reason to worry. And most of it, this is like we are talking about raw map reduce right now. Okay. Most likely, you will not be using MapReduce directly. You will be using MapReduce by the way of Piglatin, Hive, or other query languages, which will convert internally into MapReduces. Okay? Oh, thank you. Thank you. Thank you, Gunjan. It is supposed to be ACGT. Thank you for figuring this out, and it will actually confuse people. Yeah, thank you. I've corrected it. Okay, let me see. Savita is saying that the box before reducer, yes, says AC. AGC, yes, AGCT. You are right. AGCT. Thank you. Okay. And this user 4 actually belongs above. Let me just decrease its font, and then most of these users will fall together. Okay, great. Thank you again. Thank you, Savita. It is actually a typo. It should basically say AGCT. Okay. Now go through it again and let me know when I should move to the next slide. Okay. So we had user DNA, user 2, DNA 2, and so on. Now we created the key by taking minimum of the the DNA or the reverse of the DNA, and that becomes the key, and the value is the user right now. Okay. So these are the four problems. You should look at it again once the class is over. All these four problems, you should go through these and try to implement these four problems. This is the third one right now we are at. We'll talk about the fourth one as well. And once you are through with it, you should basically write all of these things in your own language so that you understand these four problems. And trust me, once you are able to go through these four problems, probably you will be able to convert almost all the difficult and almost any problem into MapReduce terms. Okay. Should I move ahead, or is there any other thing? Okay, then if you are not saying yes, that means I'm thinking that you need more explanation. So if do you need more explanation of any part in this problem particularly, or should I move ahead? Okay, great. All right. All right. Great. Now let's talk about this problem. So we have got this unusual. Okay, I've got a question from Sabita. Assuming these data files are in the system under student login. So for us to try, no, actually these data files are not there. Okay, you might have to cook up your own data. All right, because these are more, I mean, I don't have these are just a conceptual problems. Okay, so you'll have to cook up your own data to figure it out or to test it out. Alright. You'll just type like 10 strings in a file and then try to experiment on your basically session. Great. Now we got this. Great. Now this is an unusual kind of democracy where other than vote counts, the worth of the individual also matters, who voted. Okay, the voter's worth also matters. So we have given two lists. One is who voted for who, that is the list one, and second one, what is the worth of each person's, right? Had it been a simple SQL problem, this is a standard SQL joins problem. All we need to do is join list one and list two by voter, and then group by the votee, and that's all you is done. All right, so join and then group by, that's all. So how would you do the same thing in case of using MapReduce? So you have got two lists, list one and list two, and all you want is the basically for each votee Sum up the worth of all the voters who voted for that votee. So, who all people voted for C, their worth will be summed up, and that will become the vote count of the C. So, C was voted by A and B. A has got a worth of 5, B has got a worth of 1, and hence the vote count of C is 6, 5 plus 1. Okay. Or you can say vote worth. Alright. Now, F was voted by C, and C's worth is 11. And now and hence F's vote count is 11. Similarly for B, he was voted by A, and A's worth is 5, and hence B's vote count is 5. And nobody voted for A, and hence the worth of vote count of A is 0. So how do you solve this kind of problem using MapReduce? Okay, key is person, aggregate value is worth of votee. Yes. So basically you're given two plain text files which are tab separated. First file contains voter and votee. Second file contains votee, votee and their worth. So first you'll have to join these things together so that you can get worth in the same table. Okay, right? First you'll have to join these things together. And how do you join? Using MapReduce. Sum and unique of voters, yes. Votee from list 1 to give unique list of possible candidate, yes. Okay, let me see. Key is the person aggregate and value is the worth of votee. Okay, okay, okay. In map, take votee as the key and the voter's worth as the value. But how? Okay. Yes, two map reduces. Yes, two step map reduce. Very right, Ajay. Voter to votee, perfect. And then and votee to worth, perfect, perfect. And then okay, okay, okay. Arun is also right. Yes, yes, yes. Okay, 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 okay. Had it been in SQL, you had two database table. One is voter and other is votee, the first table. Second table is person and the worth. If you're joining those two together, first you'll have to join them, right? And once you have joined it, then you do a group by. A similar kind of mechanism will be followed in here also. The way the join happens in SQL, here the only way of join is creating a key which is same for two records which are being joined together, right? And when we are joining list 1 and list 2, we'll make the person as the key, voter as the key, and hence the worth of a person and the votee gets joined together. All right. And then after that, because of this thing, whatever whatever comes out, then we do the group by on that. Okay, because that the group by after that will be on the votee, and hence the votee becomes the key. Okay, okay. So I think Ajay got it right. Ajay got it right. And also Arun is almost very close. And I went through Savita's answer. So key will be candidate and value is sum of worth of voter into worth. But to compute this, it is going to be difficult because worth is in a different table altogether. Okay, okay, okay. So basically in this example, I'm trying to demonstrate how do you join two tables together. Okay, using MapReduce. So basically for joining two tables, you need to have the same key. Okay. Here what we have done is in the first case of first case we are doing a merge of two files based on A. Like we are doing a join based on a key called A. Alright. So we first said AC, AB, BC, CF, fine. Now the mapper on the second file uh, did was A5, B1, C11. So we created a singular output over here. Okay, we created a singular output combining the two into one. All right, or you can think of it as that without any reducer, we ran a mapper on the second one and produced this one, or we just combined the two files together. You can think of we just concatenated these things together. That's it. Or we can say that we gave the two files as the input to our mapper. Okay, and map did not do much here. It just let it whatever came into the input or gave as the output. Okay, so both the files are concatenated simply, and Hadoop did aggregated keys for you, and after aggregation for A it will look like, for A if you see C, B and 5 will come together, and for B C and 1 will come together. Okay, for C F and 11 will come together. So this table is actually telling you A voted for B and C and A's value is 5. Alright. B voted for C and B's value is 1. C voted for 11. C voted for F and C's value is 11. And now when you run a basically a reducer, in reducer you do a very strange thing. You all you do is you could do one more thing over here. You could basically no, you cannot do that. So in reducer you did a different thing. Okay, you basically took this output and Hmm. Okay. 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 Basically, in the reducer, all you did was you printed out this because A voted for B and C. Now B's value will be 5 because of the virtue of A. C's value will be 5 by the virtue of A. Similarly, C got 1 by virtue of B voting for him. F got 11 by virtue of C voting for him. And hence, if you explode it, if you try to make now the key as this value and key as individuals and their value, after it is all uh, grouped again, the values will come together. So everybody who voted for B will come together. But so we say whatever in the square brackets is, so B5, B got 5, C got 5, A got nothing. Okay. And C got 1, B got nothing. Okay. F got 11, C got nothing. So this is the way we can think of it. So, and Savita's question is very valid. So A and C are 0. How do we determine it? So whenever you are exploding it every time you finish iterating over your list, you print out whatever the key with the 0. Okay. C0, B0 and A0, you have printed that out. Okay. Whatever is the key. Whosoever voted for the other person, we just print out a 0 against his name. Okay, okay. Okay, so let me have a look at it. So why only A equals 0? Why not consider F? Nobody voted for A. Okay, I'll explain again to him, no worries. Okay. Yes, 0 is only for the key. You are right, Deepak. So basically here we are somehow trying to manage the join operations of SQL, okay, using MapReducer. And all those pigletin and hive and everybody will be able to do all of this for you very quickly if you know SQL. And under the hood, this is what they are going to do. Okay, so why I am actually posing such kind of problems, so that you can start thinking in terms of MapReduce when you are writing your pigletin or hive queries. Pigletin and hive will cover very soon from the next session onwards. All right. Okay. So Arun is saying that if we are iterating through the list of persons, why not iterate over why not iterate over ABCF all ABCF? Hmm, how would you iterate that? I need to think about it. So Tuhin is saying that let me explain again once more. Okay, F is not there in the list at all. Let me have a look. Right. Yeah. So his question was that okay, A 5 B C. So B became 5, yes. C became 5. A became 0. Why not f equals 0? Because f is not the key. Okay. Had it been like f is voting somebody also here, f did not vote for anybody, then we would put 0 with that. Okay. So let me again explain. So you got list 1, list 2. List 1 is who voted for who, and list 2 is whose worth is how much. And first of all, we did a simple join. Simple join because we are trying to combine together. Instead, all we want is, in case of votee, all we want is what is the worth of voter, right? And that we can do only if we can group these two or join these two table together on the basis of a key. And interestingly, key is already there in both the cases in the first place. So if we join together, we have said that our key is the first one, which is A, B, and C, and so on. So whenever the Hadoop is going to group, it's going to group these things together, and hence the worth and the votee are going to come together like this. So A voted for C and B, and A's worth is 5, and hence C and B are there here, and worth is 5 there. So this way it was grouped. So this table essentially says that A voted for B and C, and A's worth is 5. B voted for C, and B's worth is 1. C voted for F, and C's worth is 11. Now, by virtue of this relation, by virtue of this, B got 5, C got 5. So we printed out B got 5, C got 5, and A got nothing. Okay. Why we are printing A got nothing? Because we want A to be there in the output, and we want to display and rub it in and say that you got 0. Okay. But output is not voter count, but the count of votee and the count. Right. So output is basically the total worth of all the people who have voted for a person. Okay. All right. So this is the way it happens. Now, once we got this, we want to say that we want to find out all the total worth of B when voted by other people also. So what we do is we make the new key as the B and the value against it. Similarly, we do it for C and we print its value. And in other rows also, we'll printing each one's value. And mapper and reducer will again group it by the key. And in reducer, you just sum it up. Yes, yes. You're right, Savita. That's what is what we're trying to do. Okay. So think about these problems again. You'll go through each problem one by one, starting from the word count. Okay. Word count is something you should start with, and then all these four problems you should look at. Okay. So let's say Arun's question. So let's say if C did not vote for F, C did not vote for F, what would be the output? Let's say C did not vote for F. Let me do it. Okay. So C did not vote for F. Good. Now here C did not vote for F, and hence we got this. Okay. Now when we got this, C will not be there in this. All right. And hence these two will not be there. All right. And here. So F will not appear in the output list. That's your point, right? Right. That's a very good point actually. Okay. That's a very good point. Okay. C0 should not be there in the table before the last table. Then there should be one more file with the voters. Okay. Now he has got a valid question. So so basically we why I have done it. Basically we wanted to, so those people who got voted will get some value anyway. Okay. And the only other people which are left in this table are people who are voting. And hence, if we put 0 with the people who are voting, that means we got them also into the output. Even if they are not being voted by anybody, they will be displayed with the 0 against them. Okay. That is why I have put this key against 0. Okay. So in case nobody voted for F will not be there anyway here. Okay. And also if somebody is there in the worth list, say there is somebody called D who has got a worth of 11. Okay. Now D has not voted, or D is not being voted by anybody. Now what will happen in this case? Okay. Now we'll have a list like D, and then we will have 11 over here, and also we'll have D, and then we will have 11 over here. Okay. Or like we can say 12 to avoid the confusion. Okay. Now in this case also you can have D in the output. It is up to you how do you want to plan it. D as the output are called 0. Okay, because D was not voted by anybody, D did not vote for anybody, but D has got some worth as per this list. Okay, so there is this such cases also. So both the things you can take care of. All right. So should I move ahead? Yes, yes. Go on, Savita. Okay. When the data moved to Hadoop, basically it is a sort on ABC etc that produce the 5B, yes, sort and then group. Okay. Group as in that's what is called combine and merge. Before giving the input to the reducer, it is grouped. But it doesn't matter. The grouping is not such a big deal. Once you have ordered the list of things, once you have sorted, the grouping is not much of a big deal. Okay. Now, yes. So you are right. When the data move to Hadoop, basically it's a sort on A, B, and C, etc. that produced 5, comma B, comma C. Yes. I'm guessing that you have a continued question. So mapper just gave the output here. Mapper just gave the output. Okay. And a sorting happened at this stage. Okay. Hadoop took it and did the sorting and grouping in. I mean, I've just skipped one step. Okay. I've just skipped one step. But Hadoop did that. Our mapper did not do that. Our mapper just merged these things together and that's all. In fact, mapper did not do much of the things. All mapper did was took input, printed it as is, whatever there was the input files, nothing else. All right. So see, there is a difference between when I say Hadoop and when I say mapper. Mapper is a code written by you, and Hadoop is the one who is going to take your mapper, execute it against data, and whatever output your code, which is mapper, gives out, Hadoop will sort that out, order that out. Hadoop will sort the output of your mapper. Okay, mapper is your code while Hadoop's job is to sort it. So this is why this is what I'm trying to do a differentiation at. Okay, I mean it's just a bit of terminology thing, I know. Okay, now when not to use it. Yes, Hadoop will do the sort and aggregate. Okay, that is the job of Hadoop for you. When you imagine all these map reduce things, they are nothing but a reflection of sorting and then aggregation. Thank you, Raya. That's a nice question. Yeah. So in very simple word, map reduce means sorting and then aggregating. That's it. Okay. And aggregation in real sense, say you got aggregate of so many numbers, it will not apply aggregation by itself. Okay, it will not sum up all these numbers together or do any other magic. It will give your program these list of values, and that program is what we call it reducer. Your reducer will do the actual job of aggregating. I mean, Hadoop's main job will be to sort and put the values for the same key together, and real aggregation is actually done by your code. Exactly. You got it, Savita. So essentially, through mapper, we tell the Hadoop how to sort and merge. Yeah, we tell the Hadoop that you should sort by this particular key, and then Hadoop will sort it and merge it together, merge all the values for a key together. Yeah. Yes, yes. So effectively, what basically Hadoop becomes a simple sorting framework for you for the big data. Okay. Hadoop, as in when we say Hadoop, we are actually talking about MapReduce part of the Hadoop, because Hadoop comprises of everything, including HDFS and all other tools. Okay. So now all of you have understood that Hadoop and MapReduce is great for the jobs where you can define a way of sorting, where you can define a key on which you can sort the data. Okay. Now, cases where you cannot use Hadoop, there are many such cases. One such case is, say you are trying to do a fingerprint analysis, as in case of say Aadhaar card. In case of Aadhaar card, identification of each user, the let's say eye or sorts of fingerprint, has to be matched against all those which are in the database currently. Here it has to be, say, imagine that it has to be compared against each one. Okay, if you have to compare it against each one, then you cannot use Hadoop so easily. Okay, you cannot use Hadoop, or you cannot exploit MapReduce in this scenario. All right, so if the job can be done by single machine in reasonable time, there is no point of using MapReduce. The simple Unix command called sort will be sufficient for you. Okay, computation depends on previously computed values. So if your computation, as I gave you an example of Aadhaar card, where I, every new person who comes up for the ID, we need, if we had to check his fingerprints against all the computers, or all the people who have so far registered with us, then we have to compare against all of those one by one. There is no unique ID on which we can simply group. And that means you can't use MapReduce per se. So Aadhaar card in general uses Hadoop, but in a very different sense. Okay, but because the algorithm they are using, it was not, as far as I heard, it did not, it was not able to come up with a unique number for any fingerprint, or eye, whatever they call it. So that was not possible to convert into the a number, and that is what became the bottleneck in lot of project, because every new number, every new identification have to compare against all the numbers so far, all the identification so far. There was no benefit of sorting this information. If you order it, you cannot look it up by just binary search or other quick way of searching. You have to compare one by one against each. And similarly, Fibonacci series, if you have to compute Fibonacci series using MapReduce, just I'm taking a case because the next number is depending on the previous one, and hence you cannot use this one. And that is the same reason why for the other identification. You should not be using it for full text indexing because it is not incremental. Okay? Every time you have to churn the whole text. And in case your algorithm is depending on a certain central stage, or say you have got some logic which is hitting HBase in your map, it is bad design. Okay, you will end up hitting HBase in each map call, which means tens of millions of calls in a single shot, and also will delay most of the map jobs, and Hadoop will try to kill your mapper, because your mapper is not supposed, each function should not be taking that much of time to call. So if your code is depending on global state, don't use MapReduce. Okay, now how do you test a MapReduce job? First, test on very small data. Right, so let's say you come up with the idea that can we use MapReduce for preparing the full text indexes. Okay, and it sounds quite interesting, because anyway this guy is preparing and ordering and finding the unique keywords in everything, and we are able to do the sort on large text. But think of it this way: every time there is a change in your text, you cannot do an incremental indexing so easily. Okay, you will have to figure out ways to do the indexing by yourself. You will have to figure out way of doing incremental indexing. Okay, because MapReduce will again run on the whole text and so on. All right. Either you have exact diff of the previous state and the current state. Okay. So it is not for ad hoc kind of, fast paced movement of the text. Okay. So was I able to describe? Okay. So basically, because full text indexing is generally an incremental job. Okay. And therefore, MapReduce may not be a great design choices for full text indexing. Okay. But if you have got a huge corpus of text up front, okay, and your job of indexing text, basically your text is not changing very frequently, or say text changes once in a year. In those cases, it makes sense to use Hadoop for full text indexing. Okay. But the point is very valid. Why not? Why can't we use full text indexing? The answer is that in case your text is changing too frequently, it does not make much of a sense to use Hadoop because it will scan the whole text. You cannot do the incremental job with the text. There are there are standard solutions like Solar and Lucene which do these jobs of text indexing very well, and also in case your text is, say, you are analyzing the Wikipedia's text up to last year, not this year. Okay. In those cases, it is fair to use MapReduce to do that job. Okay. Now let me. Okay. Now how do you test it? This is an interesting aspect. So there are multiple ways of testing your MapReduce code. And always you should come up with your design whenever you are building any MapReduce. You should come up with your own testing strategy, and coming up with a test strategy is part of any planning or any product development. So before actually writing any code or building any kind of map reducer, you should think about what kind of how do I going to test it. All right, that will guide you and solve your problems as well. So first of all, if you are writing a MapReduce job in the using the streaming command, you can basically in, call your streaming job like this. Whatever input file you provided to the streaming job using minus minus input, you can do cat that input file, and then you can put your mapper, whatever binary or Python code you had put in the mapper, you can put that mapper here, and then use a Unix command called sort, and then you can use the reducer, and this will give the exact output what Hadoop is supposed to give. Okay, this will give the exact output what Hadoop is supposed to do on multiple nodes. Okay, this is good for a smaller subset of data. Okay, and this is quite useful. So this is how we generally test our streaming job. So we wrote two files in Python. Okay, and we are one is mapper, other is reducer. We want to test whether they are working fine or not before sending it to Hadoop. Okay, so once this is done, you are fairly sure that your mapper and reducer are doing a pretty good job. They are doing logically correct job. The only next thing left is to check whether the libraries your code is depending or these binaries which you are sending, do they exist on all the nodes. This is the only remaining testing, integration testing to be done after this step. Okay, and also make sure that you keep on testing your mapper and reducer separately. Okay, now the in case you are a Java programmer and your code is in Java, your life is made as simple as the streaming job programmer, like Python programmer, like in the third command. Similarly, people have come up with something like MR unit, which help you test map reduces offline uh, inside the Eclipse. Okay, so you upfront define what is your expected output out of each mapper and what is your input, and then it can give you a great, quicker way to test whether your logic is really doing something or not. All right, we will consider this. I will show this thing in the next class. The next session is more about, I mean, Java. Okay, so this is how it is done in case of Java. So you extend a particular class, you write a function. Similarly, you extend a particular class, you write a function, and then you tie them together with using something called a job class. So you say my job has a mapper called stub mapper, which is you defined above, and my job has got a reducer called stub reducer, which I have defined here, and then you execute it. That's all right. Now, the assignment for the next class, okay, whatever four problems I have given, okay, plus one more problem I want to give over here, okay, here, okay, map reduce, I will say it, call it 3A, and this go becomes my 3B, okay. Now, 3A is, this is 3A, this is 3B. 3A is nothing but find all the people who have only same DNAs, okay. So here user 2 is not in this group, user 2 is free, okay. User 3 and user 5, they are still the same, and so on. All right. All right, so question is okay. Now I made a problem little simpler. I call this 3A and this is 3B, okay. So in 3A you have to find out only the users with the same DNA. You have to just find out all those, and in the second one you have to find out mirror image as well as the same one, same DNA, identical as well as mirror image. So code all of these MR problem in your favorite language. When I say favorite, in case you are not hands on with any other language, feel free to invent your own language, or feel free to write in plain English language, okay. That is good for me, okay. Or you want to show me it in diagram, like this is my key, this is my value, that's also fair enough, as long as you are able to convey how is your logic getting converted into map and reduce. Even if you are hands on, just think about the whole map reduce paradigm and come up with a way to express your problem in terms of map and reduce. All right. Okay, so anybody has any questions for me? So anyway, Savita, if you want to do it on the piece of paper, okay, or whatever way, I am fine with it, as long as your code is stepwise and is working fine. Okay, Unix is still better. If you are able to write in Unix, okay. I'm okay with any kind of language you choose. I'm mostly comfortable in almost all popular languages except for Scala. Okay, so I'm comfortable with any language, whatever you write. You want to write in C sharp, write it. If you want to write in Java, want to write in pseudo language, or you want to just write in terms of mathematical steps. I'm okay with any kind of formulation you come up with. So please make sure that before we meet up next time, either you finish these code MR problem. In case you are not doing so, give me a call and schedule a time for the discussion, okay, in case you are confused or stuck anywhere. Okay, but my humble request is that do not skip map reduce problems per se. Although you will be able to carry on, as in you will be able to do a great job at Pig Latin and using other languages, but this particular concept is going to be used all across all the tools. HBase, Hive, Piglatin, Uzi, everybody depends on these two constructs, MapReduce and HDFS, all across. Okay, so make sure that you get a fair idea. Okay, fair idea, just the fair idea. Okay, great. So these questions are available on the website as well as this PPT is available to you. Okay, so you can go through the PPT again, right? This PPT will be available on the website, and then you can go through it. Also, on the within few hours, this whole session, the PPT plus the questions with the video will be available on my courses. If you log in into LMS, you can see that under my courses. Okay. Thank you guys. Thank you for great session. I hope I was not, uh, you know, too irritating for this session. And there is one more problem. Wait. I I forgot to mention this. This is something which some of you might like to work. Okay. So here there is an interesting problem. There is an assignment, very interesting assignment. You go and download the whole Wikipedia. There is a tool mentioned over here. Now, after you have downloaded the Wikipedia, yes, you can view previous class, Prashant. Just log in into my courses, and under the session 1 and session 2, you will see these videos. Okay. Session 3, which is today, will be uploaded in couple of hours. So no worries. All right. Now, here there is a very interesting question. So all of those who are using Android phone or maybe iPhone, when you type a word, it starts giving the suggestion for the next word you can type. If you say happy and then say space, the first suggestion is is birthday. Okay, first suggestion is birthday. Now, if you are building if you are building such kind of system, you are given all of these sentences all across the Wikipedia, all of the words, you have the whole text of the whole world. You have to build what is the word which follows a particular word. What are those top 5 words which follow a particular word? And you have to build such kind of recommendations. All right. Like for example, given the whole text, you might come up with after happy, people type birthday, new year, or marriage. Similarly, when people type how, you give recommendation are, do, or did. Okay. Similarly, so given all the text available, you have to come up with these recommendation where you say that uh, as soon as people type happy, we would give a recommendation called birthday or new year or marriage. We have to give 5 recommendations, but since we are having only 3 words here, we just give the 3 words. Okay, we have to give top 5 recommendation against each of the words listed in the dictionary. All right, so given a lot of text, you have to come up with these recommendations. All right, so is the problem statement clear? Although if I give you this text file, say 1 GB text file, you can start scanning from top to bottom and always figure out by maintaining a hash map what are the words which are most popular after a particular word. So this is just an example. I've imagined that most of the people type birthday after happy. Okay, these are not fixed list. I've just uh, with my imagination I have typed that after happy people will come up. People generally type birthday, new year, marriage, based on my past experience. And how, after how, people generally type are, y- or how do you do, how did you do something. So are, do, or did are the recommendation which would come if you churn a lot of data. Okay, so given a big text file, you have to come up with top 5 recommendation of the next word when you are typing. Okay, when a user is typing, you have to give the next word recommendation, top 5 next word recommendation based on just the word which I have typed just now. Okay, think about this problem. This is far more simpler than it sounds if you have good enough data. All right. Thank you guys. It was a great session. And if you have any questions, feel free to call me. Okay. In case you have not been able to follow through the MapReduce session, I suggest you two things. First, make sure you finish going through the previous videos after this class. Once you have gone through the previous videos, drop me an email or give me a call, and we will schedule a particular time, maybe tomorrow or day after. Okay, for 1 hour or 2 hour, we will again go through couple of such things in case you are stuck, because some of us have not been able to follow through. Why I'm insisting right now is, in case you are left behind now, the other things will become difficult to catch up. Okay, and you will not feel happy about the whole class at all. Okay, great, great. So thank you guys, and feel free to drop me an email. I try my best to respond very quickly. My email ID is sandeep@nobigdata.com, the email ID from which most of the emails would be coming to you. Okay, okay guys, then. Okay, thank you Savita, thank you Vijay, thank you Gunjan, and thank you Savita if you found this session great, and I'm happy actually. And Vijay, have a good day to you. Yes, yes, Arun, I would love to answer your questions. I actually liked your questions very much. And right, and feel free to connect, and it will be good. Okay, because that's the whole idea about these classes. Otherwise, there are many recorded classes available all across, and uh, um, I mean that's the only unique selling proposition I bring onto the table to be able to answer your questions. Okay. Okay, so thank you guys. Have a great weekend, and all right, bye bye, Ajay. Bye, bye bye, guys. I'm going to hang up now. Thank you very much for attending this session and staying together till the end. Great, great, great. Then I'm going to hang up now. Bye, Prashant. Bye, Iria. And yeah, thank you.